counter is one synchronous sequential, actually not synchronous, it is sequential circuit, and I have discussed with you that it is kind of two part, that is one is synchronous, another is asynchronous. The difference between synchronous and asynchronous counter is also discussed in the class. So the basic definition of counter is, it is a sequential circuit that goes through a predetermined sequence of states upon the application of clock pulses. So I was discussing that upon the application of clock pulses, we can count. So we can count starting from 0, 1, 2, 3, 4, and so on. If it is mod 8 counter, then we can count starting from 0 to 7. Okay. And depending on the clock pulse is simultaneously given or not, we have different counter circuits. One is synchronous, that is simultaneously given clock signals. See, this is the synchronous counter. All flip-flops receive the common clock pulse. Okay, the single clock pulse simultaneously given to all the flip are getting the common clock pulse. For ripple counter or asynchronous counter, the flip-flop output transition serves as a source for triggering other flip-flops. That means we are getting the clock pulse of second flip-flop from the first flip-flop's output. Okay, that already we have studied. We have studied that asynchronous started with the 2-bit ripple up counter, and we know that for designing the up counter, we should have, see, this is asynchronous type. The other name of asynchronous is ripple, and the counting can be up counting or down counting. So if we are starting from 0 and ending at 7 or 3, 0, 1, 2, 3, so we are up counting. And if it is coming like 7, 6, 5, 4, 3, 2, 1, then it is down counting. Okay. And here we have negative edge trigger flip flop. So this symbolizes the negative edge triggering. This is one JK flip flop. What is the working of set and clear? I will discuss later on. Okay, and it is negative edge trigger. So all the toggling action, if J and K both are high, that means 1, then toggling will happen at the negative pulses. So that is already discussed on the previous class. Okay, here I have given two example of a 2-bit ripple up and down counter using T flip flop. So T flip flop, if it is mentioned in your exam that draw the circuit of 2-bit ripple up counter using T flip flop, then T flip flop means what? J and K, 1 means that is toggling. So T is given as 1. The same thing. Okay. And the new things. Okay. So this is the clock timing diagram. Okay. And this is known as the state diagram. So something new. Okay. In the class, I have discussed with state table. But now it is the state diagram. So we have to draw this state diagram. For up counting, the first state is what? That is 0, 0, 0. Okay, this is something new I'm discussing. 0, 0, 0, and after that we are counting 0, 0, 1. After that 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0 again. So it is again. So this is a circle kind of thing. It is a state diagram for 3-bit ripple up counter. Okay, it is same for negative edge triggering and positive edge triggering, because the timing diagram will give you that 0, 0, 0, 0, 0, 1, 0, 1, 0, 1 by 1, right? Because the state table and state diagram, they will be same for the negative edge triggering or the positive edge triggering. What will be the difference? The difference will be at this bubble, that is symbol of this clock. And if we are using this positive edge trigger, then we have to take the outputs from Q bar, right? Or the clock from Q bar. So actually this is, see, this is again we are taking the clocks from Q bar. Okay, and we are taking the outputs from where? Q. And this is negative, so that will be down counter. We are counting like from 111 to 000, right? 111 to 000, and again we are getting 111 for down counting. So this is one positive edge triggered. See, the bubble is not there. It is positive edge trigger. You can follow that. If any query you have, you can ask. So this is JK flip flop again, positive edge triggering. So when the clock pulses are positive edges, at positive edges, outputs will toggle. Okay, Q0. And for Q1, Q0 will act like the clock. So they are toggling here. And for Q2, state table is shown here, that we are counting from 0 to 7, as it is 3-bit ripple counter and up counter. Okay. Next, this is 4-bit ripple up counter. So I have already told you in the class, just you have to add another JK flip flop and the state diagram will be elaborated for Q0, Q1, Q2 and Q3. We have Q3, the added thing. We now have Q3 here, and it is again negative edge triggering. See, the bubbles are there. So negative edge triggering. So we are taking the outputs from the original Q, and clocks are given from the Q only. Okay, here this line is missing. It should be joined. Okay. So whenever the pulses are at negative edges, they will toggle. And for Q1, Q2, Q1 will be the clock. For Q3, Q1 will be the clock. And just changing at this negative edges, and we will get the up counting. Now steps for down counting already discussed in the class. Just if we change any one of these, then down counter. If any two of these, up counter. If any all three features are changed, then down counter again. Now the state table for down counting is already discussed, and this is 4-bit up and down counter state timing diagram, clock timing diagram I have given. Okay, you can draw the state diagram as well. That 000 state diagram. The process of showing state diagram is this. You have to draw like this. Okay.